Okay, so we are going to do a quick tutorial video on how to make my level 3 armor for people who need it um, in places where it is difficult or problematic to acquire factory made armor. So what I use is 1/8 inch AR 500 steel as a backing plate. So this is going to be towards you. Um, and then 3/4 inch HDPE. This is going to be towards the people who are shooting at you. We want this to slow down the rounds before they get to the steel. So it's kind of reverse of the standard way that armor tends to be designed, which is the hard surface towards the enemy. I use this out of a factory made. This is recycled HDPE. And this is virgin AR 500 steel. However, I have done testing with home recycled HDPE, and it works about as well. But since I sell these, I don't want the possible inconsistencies that can come from this. But if you're in a position where you need to make your own body armor, the HDPE is the same plastic that milk jugs are made out of, and a number of other things. Whatever symbol or whatever they call it where you are, it's almost infinitely recyclable. So you can cut it up, throw it in an oven. You want to use either a non-stick pan or get some like parchment paper or something like that to put under it. And what you're going to do is put it in the oven at about 400 degrees Fahrenheit or 230 Celsius ish. Ovens vary. Start low, work your way up, and just let it melt into a cohesive mass. And then you're going to want to put some wood or another pan or something over this and clamp it, because HDPE warps pretty heavily when it hardens. So because you want at least one flush face so that when it is sitting up against the steel, there's no gap for the plastic to expand into or for spalling to come out the sides. But from testing, honestly, like the way the steel deforms tends to keep the spalling to a minimum, so there's not a whole lot of shards. It's not the end of the world if there's a little bit of a gap, but you want it to be as flush as possible. And then with the steel, you want to drill 4 holes in the material, and then have 4 holes in the plastic at the same locations, so you can run the connection between the two. I use 1/4 inch rivets. You could do bigger. I wouldn't go smaller. This provides an awful lot of strength. These are mild steel. I've not had any issues with the rivets breaking under impact with that. You can also use mild steel bolts. You don't want to use stainless steel. It will snap instead of deforming under impact. So I recommend mild steel, but a normal bolt and nut should work. This is just because I have access to these. This is what I use, and it works really well. So I just put it through with the rounded head through the up to the plastic, and then hammer it flat on the backside on the steel, and that gets a really good connection. And when I hammer it in, I hammer until the head is recessed into the plastic, just so it's smooth and that the rivet swells inside the material to kind of lock it in even better than just having the two riveted sides would be. Just in the off chance that this gets damaged, there will still be a good chance of it being somewhat locked together. The two main styles that I use are the square plates. This is great for your back or the front if you're not intending to shoulder a rifle, or the rifle cut here. This is so that there's space on your shoulder to put a rifle up against without having it on the plate itself. So this is good for the front. This is good for the back because it gives more coverage. As far as the materials go, the AR-500 steel is pretty common in construction equipment. So if you can get your hands on a like a bulldozer bucket, that's going to generally be AR-500 steel or something very equivalent. And so you can just cut it into shape and then use the melted plastic as the front, and it should function more or less the same. You will need it to be at least 1/8 inch thick. It can be thicker, both on the steel and the plastic. If that's what you end up with, it's just going to weigh more and be a little bit more bulky. But so 1/8 on the steel and 3/4 inch on the plastic is the minimum. And then what that should do for you is give you a solid level 3 armor that's relatively lightweight. This weighs 7.2 pounds. And as you can see, it stopped 30-06 and 223 going at about 3,100 feet per second out of a 20-inch barrel. And it stopped them everywhere. The places where it didn't are where multiple hits hit the same spot, and that can cause problems with high velocity rounds, multiple hits on the same spot. But 7.62 by 39 and most shorter barreled rifles, multiple hits don't seem to cause too much problem. But with, a 30-06 or high velocity 223, 5.56, multiple hits in the same spot will cause a failure of the armor. But it doesn't compromise the rest of it, so it should still work just fine. So yeah, that is more or less all there is to it. So to recap, you want at least 1/8 inch thick AR-500 steel or equivalent, which can come from construction equipment. 3/4 inch HDPE, which you can melt down for yourself in an oven. Don't do it in a sealed room. It will off gas a little bit, and that can be unpleasant. And then just rivet it or bolt it all together, and it should be good to go.